welcome everybody. My name is Dino Esposito. I do some work for JetBrains, that people who are active, especially in the Microsoft stack, but not necessarily also in the Java space, know this company very well for the tools they do. What they do has not much to do, actually, with what I'm going to present in the next hour and a half or something like that. The sketchy thing and the comeback of flowcharts and top-down refer essentially to a common sense approach. I'm in doubt whether to say a new common sense approach or just a common sense approach to the whole process of software development. It comes from years of personal involvement as a developer in the beginning, but more recently as an architect and as the chief architect on projects in a very specific business domain. But managing these projects told me a few things that basically I'm ready to share and overall qualify as a new, yet another common sense approach to minimize or at least to keep under control the costs of software development. So essentially we are talking about requirements, user requirements. I think everybody can agree that most of the costs, direct and indirect, of software projects depend on user requirements, how we understand them as architects, and how we handle them, how we pass considerations, instructions that we learn from requirements to the actual people, whether ourselves, our team, or companies living the other side of the world we outsource it to, instructions on the actual code we want to build. The second two blocks in this talking about slide refer just to what I call the solution to the issue of a different, more common sense way of handling requirements. Sign off at the presentation layer. This is the new idea, if you allow me to use this engaging word. Oh, it's a new approach. Wow, we have a genius in front of us. Okay? No, it's not like this, but anyway. UX first, related to signing off at the presentation level, is the point that says, okay, we are, at the end of the day, just selling a user experience, so a mix of graphical artifacts, whether a web page or just the front end of a client, a rich client application, to customers, and they work through the tools, graphical and logical, we provide. And the point that I feel to share is most of the time we miss at that point. Not much in the back end, not much in the logic, but in the way in which we offer functionalities, the experience, the way in which we build and study and arrange the final experience. So UX first is the top name for this relatively new, and I like to call it common sense approach. Now, developers and architects, we are not completely idiots, okay? So if we do things in a way that in the end costs us some money, there should be a reason. There is a logical, extremely logical path that we apply, we use every day, that has to be revisited at least. So let's start seeing where we come from. The generation of today's architects, more or less, comes from the 90s. And in the 90s, when we learned the base ground of programming, we had a few assets that not in the same way exist today. In particular, we learned to code and architect systems relying on one powerful, extremely powerful server machine. And then just a few relatively slow personal computers, just clients and one big server. More importantly, we had, okay, imagine now you are face to face with yourself in front of a mirror. You can say that. We had for years a generation of users and users passively accepting whatever interface we were giving them. That's it. I did that, you did that, so it's everybody faced this point. So because of this mass of users, we never probably spent much time focusing on the experience, including the interface we were offering to our users. And we thought, maybe reasonably from the perspective of the 90s, we focused much more, we reckon a lot more important to focus on the database, on the optimization of the database code rather than what we were giving users, because they accept whatever we do as long as it works quickly is fine. Today, we have, unfortunately or fortunately, depends, different assets. In particular, we have so many fancy technologies. So it's no longer just about learning how to code effectively a storage procedure running within SQL Server or Oracle. There's a lot more we can do from the data level up. We have not just one or two dummy PCs, but we have myriads of client devices. And many of them belong to classes completely incompatible. A smartphone is not a PC, a laptop is not a tablet, not to mention wearables or whatever else. Whatever other fancy technology will come up and show up in a matter of months. And worse yet, we have now a mass of users not passively accepting enforcements, but actively dictating what we should be doing. So the user interface, the consumers of our software are now totally different. And that is the generation of, well, the present, but more importantly, the future. So any piece of software, any enterprise system that has customers or end customers, some sort of consumer level in it, should take into serious account the experience that is actually provided to users. But even when the enterprise system is created as a line of business app to be used within the company, well, money is still involved because a user experience that is less than optimal can take employees to spend a lot more time for doing the usual tasks, achieving the usual tasks they are supposed to do. So it's, in the end, instead of being a direct cost, it becomes an indirect cost, but it's still a cost to the company. So we live clearly now in a different world, but we still, in my opinion, for the most part, try to build software as if this big change in the software world never happened. In the 90s, we had powerful databases. One, SQL Server or Oracle or maybe DB2 or maybe SAP, but one big server machine. Super optimized code running within that machine. It made sense 15 years ago because the company spent a vast mass of money to have that server, and reasonably the company wanted to take the most out of that machine. So optimizing, having the wicked machine to work as hard as possible, that was precisely a way to keep costs under control. Do you remember Windows SNA server? It was around late 90s, 2000s. It was a fancy technology, Microsoft technology, to wrap up COBOL procedures, typically but not necessarily in banking environments. Or COM, MTS, Microsoft Transaction Server, DCOM, those kind of things. Oh, we had Visual Basic. So the combination, Visual Basic for the client, where, okay, it doesn't matter the PC is slow. The PC is always slow because the PC is not the server. So Visual Basic is more than fine, and it allows us to quickly arrange nicely user interfaces. Oh, the real meat and potato is on the server. A generation of architects has grown with the idea that all that matters is the backend, and there is no need to pay attention to whatever exceeds the server environment. Because, well, just a few buttons on a Visual Basic form, that's it. That's the trick. It works. Users? Users? They pay. They don't care. As long as they pay, we're fine. So, pillars of the software architecture of the 90s are essentially four: bottom-up development from a solid relational model up higher layers, just moving families of records, collections of records, down up the stack. Subsequently, business components were typically vertical components, just built from one key database table. I'm going to tell you something about the DDD, okay, in just a few slides, and even more in a talk I will have tomorrow. But in domain-driven design that I assume you, for the most part, know at least the basics of, there is a concept called the aggregate root, which refers in the DDD terminology to a particular class that then you have to persist to something that happens to be an aggregate root database table. It's the same concept if you get rid of terminology related to methodologies and fancy names, but the concept is the same. A key piece of information with pending, related, less important pieces of info. So we just identified in the 90s the key tables in our database and built vertical components capable of doing whatever crude operations, but also business operations on top of the contained data. And we had no classes to express the behavior. The behavior, whatever business logic we needed to have, was already in components tightly bound to database tables. So we just needed a few containers, data containers, to bring data up to the presentation layer. Sometimes they were just record-like structures, ADO.NET record sets in the Microsoft stack or similar in other environments, or just classes, but just DTOs, data transfer objects, anemic model, so with no behavior at all. And then we ended up having three typical layers: presentation, business, and data, layers or tiers depending on the idea of scalability of 15 years ago, in which, breaking layers in tiers, so in physically separated components, and spreading out those components horizontally by multiplying them with load balancing mechanics, or just making that particular machine much, much more powerful, okay, gave us the improvements in scalability we needed. So this was the 90s, the core of our enterprise architecture. Past the 2000, something started to change. One of the things that we observed, one of the phenomena we observed, was the appearance of domain-driven design. And domain-driven design, as we learned, as many of us learned in the past years, had a couple of concepts which are absolutely critical in DDD as a methodology, but have been kind of misunderstood for years. And nicely enough, the most prominent guy who misunderstood the key concept of DDD was the inventor himself of DDD, Eric Evans. There is a YouTube video of 2009, was a QCon conference here in London, in which Eric Evans says, the title of the talk is, "What I Have Learned About DDD Since Inception." So the book, the DDD book, the blue book, was published 2003, 2004. So 5 years later, the same author confessed, and it's a great point about the person, the individual, the man, confessed, well, actually, there are a couple of things in DDD that needs to be given a different shift. And the two things are essentially ubiquitous language and bounded context, which in the idea of DDD that most architects have today are just, okay, like the principles of object-oriented design. You must work out classes that represents the entities in the domain. Okay, yeah, that's obvious, too much obvious. Let's go to the real business and ignore, it's a generic reminder about, no, ubiquitous language is a very, very serious thing. It's the most important part of DDD. Has the same Eric Evans, he had the brilliant idea of naming the thing ubiquitous language and to justify that to architects, but he himself, in the book, failed in giving ubiquitous language and subsequently bounded context, so subsets of the business domain where the ubiquitous language changes, the due importance. And I'm going to talk about this particular points more tomorrow morning in my talk about DDD misconceptions. But anyway, domain-driven design brought a solid, object-oriented metaphor in which something called the domain model, so the all-encompassing, comprehensive representation of whatever happens in the business space, that has to be represented through interconnected objects. And whatever could be labeled as anemic compared to rich domain model, the difference is all in how much behavior you code in your classes. So an anemic model is a model, an object model, made of classes that mostly have properties. Getters and setters, but essentially properties, no methods that perform logic, algorithms, right? Domain model is instead where you have classes that represents entities and entities with their data, but also with their behavior. So everything, at some point, even in the .NET space, started moving towards objects. By the way, in the Java space instead, the whole thing started a few years in advance. So now, the classic three-tier architecture expanded in 4 layers. And also, layers or tiers became less relevant in the sense that it's more important just to identify layers, so logical split of functionalities. And then whether or not you turn a layer into a physical tier, so you implement any of those on a separate machine running in a separate process space, that is, well, something that has only to do with the level of scalability and performance, overall performance, you expect to reach. But from the design point, layers are important as well. So we have 4 layers now, with different names also. But the infrastructure layer is essentially the data layer that we knew for years, except that the fancy new technologies we have today, one name, NoSQL, technologies, really take us to give elements in the infrastructure layer essentially any form. It can be what is called polyglot persistence, in which you use, I don't know, something like graph databases to store certain pieces of information. You can use Redis or Cassandra or in-memory caches to store in a format that is immediately easy to consume from the upper layers, already there in memory. And then you can have also relational databases for physical, classical persistence. So the infrastructure layer is about data, but it can have participation of other technologies like polyglot persistence, so no SQL, but also caching, and also, why not, dependency injection. The business tier that we knew for years now was split in two parts, the application layer and the domain layer. So they are two phases of the business logic, because we got to know, to understand, to figure out that actually the business logic is made of two parts. And just this distinction was a kind of gray for many, many years. So where the orchestration of the use case belongs, is it core part of the business domain, or is it just that it belongs to the application we build for that domain? Today, think of when you have clients significantly different from classic laptops. Think, for example, to websites, right? The content we offer through the website today must be offered for business reasons through mobile applications, or even mobile sites, which are websites specifically built for that particular scenario. Now, in the screen of a mobile, whether natively through an app or hybridly through websites, well, you cannot fit in 4-inch what usually goes in 13, 14, 15 inches. So the 80-20 rule, so you only need 20% of the full content to go to reach mobile users, holds. And in the 20% or whatever of the functionality and the behavior you really want to have offered to mobile users, it's not unlikely that fall completely different use cases. So it's not just about serving them less data, but also data served in a different way or new functions at all. And when we talk about new functions at all, okay, it's business, but either we call it business for a completely new application, which involves duplicating part of the logic because it's the part of the logic we use to manage the core elements of the domain. Or it's just a different part of the higher level of the business logic. So application and domain layer are two phases, one on top of the other, that expands to form the today business layer, in which the application layer is where you just have the orchestration of use cases for all the possible presentations layer you may have. Mobile, desktop, this or that. The domain layer is invariant, is the part of the business logic that is completely invariant, ignores the customers. So in a way, in the domain layer, you find the logic about the banking domain. The application layer contains the orchestration of user interface tasks as they are requested by the various presentations. So if you add, at some point, yet another presentation layer, you probably need yet another piece, an extension to the application layer just for the use cases, for the orchestration, the flowcharts, okay? You have to implement, but then the flowcharts, the new flowcharts, end up calling into core functions you still find in the domain layer. That's why the domain layer is where the most interesting things about the business happen. And the presentation layer is the most critical at this point. Because if we don't know exactly what's going to have there, whatever else we build below the level of presentation can change at any time. And this is precisely what happens today, taking the costs of development to be significantly higher than expected, or than usual, or than reasonable. We don't know exactly what we want to produce. That's the point, as I say things. Okay, feel free to disagree, but that's my perspective of things. We write software without having clear the reason and the scenarios we are writing that software. To this, add that even when we know clearly the use cases we are going to implement, there is the second factor, the smartness of users, which don't content themselves anymore with just a piece of UI that allows them to work reasonably, I would say. So it's about identifying the right use cases and the best ideal experience for each of those use cases. This is something we have to sign off ideally before we start building the foundation of the system. So instead of bottom-up, we completely turn it around. It's top-down. The foundation becomes the presentation layer, and whatever else is a sort of a black box. We can even start developing at a later time once we know exactly, and having signed off, what kind of data we are expected to send to the UI and receive from the UI on a per case, use case basis. So effects of the DDD revolution, long-term effects are business layer split in application and domain layers. Definition, new definition of what is a domain layer, which is essentially pretty simple to understand. It's where you have the mechanics of the system, yet hard to adopt because, and now what? And this is where things like CQRS or even sourcing these days, hot topics, hot terms in the software architecture come into play because they are ways to improve the way in which we adopt the principles of domain-driven design. DDD, this said, so domain-driven design, which is simply a methodology that helps us designing a system driven by the business domain. So domain-driven design means exactly what literally it means. Design driven by the business domain. But it is often mistaken and oversimplified to be just, okay, a collection of objects and persisted through entity framework or an hibernate, and the question becomes, is it better to use entity framework or should I use an hibernate? And we focus on critical technologies, but yet implementation details in the context of a large enterprise system. Okay, let's talk about overall methodologies for projects. We observed in 10 years at least the waterfall model to go to the stake, burned to the stake, and agile to gain the limelight. I have nothing, of course, against agile. It's great. But probably, no, waterfall was not wrong. It was not wrong. The idea of waterfall, okay, sign off each step and proceed to the next only when you're done with the previous, it's not per se a bad idea. Adopted, it turns a total mess and completely obsolete, not just adequate to the times we're living. So agile is much better in this regard. But if you are too much agile, too much of agility, well, it doesn't give you the strength to stop at some point and lift the world on the strength that your leg, just because you're standing in some place, can develop. So, okay, waterfall, the classic waterfall is out of place, out of question. But also I would say rethink about what agile takes you to do. It's great to change, to rewrite, but you change and rewrite what? User requirements. We are now used to the idea that we discover user requirements on the go. Day one, we have some sort of understanding of what we want to do, And we start writing code. Code first, code first, code from day one. Maybe a sprint 0, just not start coding and stopping in the dark. Okay, great, but at that point, it starts a process in which you start coding on a faint understanding of what is the final destination. You know that you are going west, but west from London can mean, a wide range of final destinations. You probably need to gain more details about the final destination to define a path, maybe not the optimal path right away, but a path that can take you there with the smallest possible number of iterations, of requests for changes, right? Because every request for change may be more money for the software house if you work for hire, but it also brings the costs up for the buyer, and this is never a great news, even for the software house that works for hire. So when costs go up, not necessarily is a great news for all parties involved. So we complain that requirements change constantly, but why they change constantly? One possible reason, and take this as a small doubt I'd like to humbly instill in your minds because it's been in my mind for a long time, is maybe it's also because of the way we architects deal with requirements. The agile iterations probably, spin up too often, too quickly, without giving us enough time to learn and figure out what we're doing, why we are running that particular sprint. Discover on-the-go requirements and requirements that change constantly, they go together. They are tightly and strictly related, and both contribute to raise the average cost of a project. It's their mechanics. That's it. It's part of it. It's physical. It's just physics. It's a different world, but we keep on designing code as we were in the 90s from the database up. You can agree or disagree with this. But this is the foundation for the common sense UX first design methodology that I'm going to introduce now. So, relax for a few moments. This is a very popular Dilbert strip. I think this was created in 2001. So 15 years ago, sort of. So it's a long story. Your user requirements include 400 features. Do you realize that no human, will be able to use a product with that level of complexity? And the answer, I think everybody can guess what the answer is. Oh, good point. And for a moment you think, wow, I can't believe I have a counterpart, a stakeholder that understands business. No, it says, good point. I'd better add easy to use to the list. Okay? Trying to express the same concept graphically, going back to, so why? We are building systems like this. We have a foundation. They told me not to trespass the border here. Okay, sorry. We have a foundation here, the solid foundation represented by the database and the data here. And we expose, because that's the foundation, we expose hooks for higher levels of code to connect to. And at the end of the day, we end up instead pushing something that, from the top has to connect to what we have defined at the beginning. It represents the foundation of the code. And sometimes, what comes from the top and what emerges from the bottom, they don't match. Just like when, I think it was the Second World War, someone attempts to take train tracks to Russia to figure out that the width of tracks was different. We often have a sort of a problem like this, and when we have this problem, when we face this problem, well, it's a cost, because something has to be changed. UX first. The idea is having two different roles of architect, not necessarily two different people. Roles is not necessarily the same. So its role is a job. So a role in a job. So it could be different people, or it could be new skills added on top of the same physical individual. The software architect, as we know it today, the blue pill, which does interviews to collect requirements, extract business information out of requirements to build the domain layer. And the UX architect, which in parallel interviews the same users, or interviews end users in particular, so with the same users but with a particular focus on end users, to collect usability requirements, and on top of that, build what they think to be the ideal user experience to be implemented in the presentation layer. So it's two different things. And today, we do the blue part. For the most part, we don't care about the red part. Or the best we do today is delegating the red part to a design company or a designer we hire, often a designer we don't even have in the company, but that works for hire from the outside. And in doing so, we probably look at the costs we may face if we bring the guy within the company. It becomes a fixed cost. But we ignore, most of the time, the indirect costs we have by having the guy work from the outside on such a critical part of the project. The point is that we just don't realize how critical the user experience and the presentation layer is. Architects of the 90s still think, yeah, it's a bit of buttons on Visual Basic form. I'm the first. So, yeah, if you remember the blue pill, the red pill, I think it was Matrix or something, yeah? The blue pill was, would you like live in a world of illusion? In this case, it's the developer illusion that if you have a database that rocks, you're fine. Or the red pill, experience the real world. Okay, you can even have the world's strongest and fastest database, but if you don't put users and users, if you don't enable them to actually trigger the tasks that will make the power of the backend shine, I'm sorry, but you're lost. So concretely, how can we try to achieve UX first? I think it's no more than 3 key steps. No code, just 3 steps in the way in which we plan software development. The first thing, preliminary step, the first step we run preliminarily is having clear the use cases. Okay, the screen we have to produce. In the end, a software application is a collection of screens. And even if you do, in a web scenario, single-page applications in which you have just one or just a few HTML pages that change content dynamically, by screen, I mean each individual piece of functional screen you offer to your users, regardless of the number of HTML pages you have in a single-page application scenario. But if you think about ASP.NET websites, I'm talking about the number of ASPX pages, or if you're doing MVC, the number of razor views. So once you have clear the number of screens and the content, a rough idea of the content in terms of graphical elements, data elements, forms, you have to put there. The first step is for each of them, build up UI forms as users love them. But it means that you have to go back and forward to users to make sure that they love it. They feel they can work effectively with that user interface. And at this point, you are not writing any code yet. Second, when you have clear in your mind what you're going to serve to users, you define workflows, because every screen, this is a UML that says that, okay? The use case diagram in a UML, so it's not something I invented myself right now. The use case of a UML says, define actors involved in a use case. So in each screen, it should be clear that, okay, the graphical elements you want to have, partly defined by the UX architect, but also the actors. So the actions, the triggers, the data to be shown and the actions to be triggered against the back end. And each action, each clickable buttons, each piece of UI that triggers an action to the back starts a workflow. A workflow in the end is a flowchart. Here, the connection with the flowchart in the title of this talk. So define workflows from there. And workflows define the application layer. Then, the obvious final step is connect workflows to BizLogic. And at this point, create pieces of BizLogic that can be reused if you're good at that, or just vertical components. At that point, the domain model comprehensive approach of DDD becomes just one possible implementation detail. Because BizLogic could be, if you feel good at that, it could be a comprehensive model. If you don't trust your developers, if you don't trust yourself, if you don't like the domain model idea, you can even go with plain vertical components in terms of pattern, transaction, script. In nicer terms, CQRS with read and write stacks completely separated. It may not be fancy if you build a case study on, because you're probably not using or not immediately using fancy terms, but your code works. Definitely works. Simpler, effective, straight to the point. But today, with the complexity of today's software, straight to the point that works, it's the best, okay, attribute. It's the best statement one can make about a piece of software. This arrow, this line, this timeline is not continuous. It cannot be continuous. Because if you don't put a breakpoint right after or right before the workflows, you are constantly risking to go back and iterating between the two parts of this, let's say, so software architecture islands, and trespassing, building bridges, okay, across architecture islands can definitely be costly. And for what I know, for what is my experience, this is the sore point of most architecture these days. Sign off, summarizing, sign off on what users really want. How? There are 3 tools we can leverage. Sketches and or wireframes and mockups. I put sketches and wireframes at the same level, meaning that, depending on a context, you can use only wireframes or only sketches. Not necessarily you have to go through sketches and wireframes. You likely want to use mockups. Going straight with mockups which is something I've seen happening often, is risky, in my opinion, because the sketch or the wireframes gives developers, architects, a clearer idea of the layout of the screen they have to create as the end point of the back end. The mock-up, because it's confused with graphics, with graphical elements, a mock-up is just a PNG. It's a Photoshop file. You risk of getting lost in terms of how constituent elements, data elements really work together. Mock-ups are fantastic for end users. But for developers and also for users, two steps, sketches or wireframes and then mock-up together works. If you have time only for one of them, I would recommend you go with wireframes. And once you have, once it's clear what users really want, you build prototypes from requirements. Now, I would recommend not writing code at this time. So you iterate. So the sign-off comes here. So you talk, you figure out, you create wireframes, and you get approval on wireframes. Just, removing things that it's clear that they don't work because you misunderstood, you got it wrong. They explain it wrong. There might be several reasons why the message doesn't reach in the right form. But changing a wireframe is changing a sort of VCO diagram or a PowerPoint or a balsamic file. When things start solidifying, if you have time and budget, you can produce mock-ups. This is what you're going to get. Is that okay? Yes, it's okay. If you have time, and I would recommend finding time and budget for that because it saves money later, build a prototype. So a quick idea, okay? The system is going to work like this. If you're talking about a website, put a website on and let users play. There's no logic attached. It's just the user interface, the presentation. Is this the way you want to work? Because it's just about creating a few interactions a navigation between web pages or XAML front ends. It takes time, but it's not a huge amount of time. It's extra costs. Yes, but it saves money. Not in the long run. It saves money soon, right after that. Because once everything has been signed off, it's the first step of old waterfall methodology. That point onward, you're on the right track. I mean, okay, we live in an imperfect world, so nobody can give you the absolute certainty, okay, that you are really on the right track. But the odds are not against you. So it's really, really likely that you are on the right track. There may be still room for going back and change things. Okay, but that is probably a reason that, strictly depends on business. Especially if you work with startups these days. It's not completely clear what they want and how they want to do it. So in this case, they may sign off one day and then change idea a week later, a month later, 3 months later, when the full product is not complete yet. Be ready to this. But there is a strong evidence in this case that the change occurred because of a business change or a different perception of the business. It's not that it has to change because you got it wrong. Or with the excuse, but the text or the Word document was not clear enough. Well, honestly, the primary role of an architect is making sense of requirements. Don't expect the requirements flow in from the customer in the right form. It's you, part of your classic software architect job role, to get back to customers to ask for clarifications. And the things like ISO architecture requirements, usability, scalability, blah, 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 classes of attributes, those boring things, they exist just to guide you on how to treat the mass of incoherent, abundant, sometimes lacking, but requirements. They come in a very raw form. It's your job, it's my job, it's your job to put order in that mess. But if you don't know very, very in depth the domain, if requirements are really incomplete because the stakeholders themselves don't know exactly what they want, these are part of the real world, but I think, honestly, humbly, that this approach, you put evidence in front of the users. Hey, you look, you asked me this, working in this way, as the prototype demonstrates. Okay, you change, it's okay, but you pay now for this. Okay, I used a few terms, sketch, wireframes, prototypes. Let's clarify what they mean. A sketch is a freehand drawing. Okay, typically it's done on a napkin, okay, when you are sitting in a restaurant during a business lunch. There are tools, Balsamic is one of those, that help you, start sketching ideas like this. But in general, a sketch is just a freehand drawing. A wireframe is a more precise sketch where it's clear the layout of the screen, the navigation logic, the content, and the storyboard you are going to build, so the connection between different wireframes. It doesn't focus much on UI details, whether it's a combo box, it's a list box, it's a pop-up, a pop-over, yeah, tooltip, yeah. It's not at this level of detail, but all of the pieces fit together in the form, in the rendered diagram, and the navigation from one piece to another is clear. And finally, a mock-up is just wireframe with some sample UI attached. And in this case, we are just talking about CSS or graphical themes, okay, on top of a clearly defined layout. And a mock-up also involves a technology. So because if we are talking about a website, it's one thing. If we are talking about WPF, it's going to be something different. I mentioned prototype. Prototype goes hand in hand with other two terms, one of which is proof of concept. Proof of concept is a small exercise, so running code, but a small exercise to test an idea. Or maybe to just play experiments with a new technology. You write something just to see if it's doable. That's it. A prototype is not to see if the idea can be taken further. It's when you take the idea just further. And further means a system that simulates the full system you're going to build with some missing pieces. What I typically do when I build a prototype is UI only, maybe not the final UI, but some UI, so where it's clear how the system navigates from page to page and what each page does. So typically data collection and rendering. There is no business and data in the middle. If I need to persistent data, I use a SQL Express. And I use canned components, where data and logic is just hard-coded. Very simple, very basic, but still serving data in and out has the full system it was supposed to do. So users can see face-to-face if the system is, once you just attach the real logic, works the way they like. And finally, a pilot, just to complete the terminology, a pilot project is a full production system, okay? But put on stage, okay, typically on a staging.site.com, okay, working on a subset of the general intended audience or data, or audience and data. But it's the full system, not working, okay, as in production, in a smaller, simpler environment, but a full system. Okay. The point of capturing, the point that should give you immediately the ROI, the benefit of UX first, is catching bottlenecks in the user experience. Like it or not, it's there that the problems arise. So when users require changes, okay, it could be that they missed an attribute, a piece of logic, but sometimes complaints come from the point of usability of the user interface. I don't know how you are here, how it works here in the UK, but in Italy you cannot find a public website for a train company to mail company that works as you expect. I mean, buying a train ticket is it's a mess. I got it, my God. I've been able to, a friend tweeted last day, I've been able to buy a ticket online, a train ticket online from trenitalia.com. I've got refunded for a train ticket from trenitalia.com. I can't believe it. So avoiding these extreme situations is just the purpose of UX first. And I would recommend, it's much better to invest time on really understanding the expected and ideal mechanics of screens and related tasks, rather than to understand what was the real intended meaning later and write code fixing, trying to reuse the code that already exists. It takes more time, sure. That's why I call it a responsive waterfall, in a way, right? It takes more time because you have to justify, if you're not the project manager yourself, you have to justify this extra startup costs and startup time because you actually start producing code. But, I think it's obvious to software minds, okay, the benefits of the approach. If it's clear where you're going, you go. You just go. It takes the time to write code, but you don't have to, you write code straight, not you write code, having a lot of curves along the way. Domain modeling, that's another critical point, a misconception we inherited from from misunderstandings of domain-driven design. To me, sometimes it seems like developers and architects think like they're God, and they have to create and express the world. No, it's not like this. Domain modeling has to be functional to what you're doing. And you know what you're doing if you, either if your stakeholders are so great at describing what they want through requirements, or if you are so great at understanding and figuring out screens and tasks with the approval of customers. Either way. Most the second way. So the model has to be function of screens, and functional only to what screens and tasks and related tasks need to do. Let me give you I think it's a great example of what I mean by a model that it is functional to what you're doing. This is a geographical map. I invite you to focus on a couple of areas here. Alaska and Brazil. Now, question, looking at the map, is Alaska as large as Brazil? I would say yes. Looking at the map. Sort of. Would you believe that instead the real size of Brazil is 5 times the size, the extension of Alaska? Okay, you may say, okay, Brazil is larger than Alaska, but it's not certainly 5 times larger. So the map is wrong. It depends. The map is perfectly functional to a particular business domain. Of course, because it's functional to a particular business domain, it could be non-functional, so wrong, in another business domain. It's all about understanding what is your business domain. Now, this particular map is not a Google map, okay? But it's a Mercator projection map. I confess I had no idea what a Mercator projection map actually was until my co-author on the recently received Microsoft Architecting Application for the Enterprise book told me. So actually, this is an excerpt from the book. The Mercator map is a model that deliberately distorts areas and distances, especially when you go from the equator up and down to poles. The scale becomes infinite, so the more you go farther from the equator in both directions, the more the scale used to render geographical areas becomes infinite. So the Alaska, which is at the top, is much smaller than it actually is. And, okay, so there is a reason, and nautical cartography, that's the reason for the Mercator map. And I would like to be able to, because I'm not able to repeat this, so I have to read to explain what is the business reason for having such a Mercator map. So let's read that together. Essentially, when you draw a course, okay, on a Mercator world projection, the angle between the course and the equator remains constant across the meridians. And that means, I saw some face, I don't know if it's true. I'm just quoting. But anyway, fact is that since the 16th century, this projection has been used to travel the world. And in the 16th century, it was the time in which Columbus discovered to the America, and Portuguese explorers found about Africa, the South Africa, the Good Hope Cape, Australia, later on, and so forth. So it worked in the end, okay? So there should be a reason for that. But actually, the Mercator map compared to Google map is different. You see clearly the South America continent or the Africa continent is stretched, because one of the key rules of the Mercator project is that every square, regardless of the size of the square on the map, refers to the same geographical area. So the square area is the same. But anyway, if you are writing software for nautical cartography, you don't need Google Map. You better need the Mercator map. You say, well, but I'm representing a distorted world. Yes, but that distorted world is functional to the business domain you're in. That's it. It's so simple. So responsibilities of the new figure of a UX expert. So I told you that it would be ideal to have two architect roles, classic software architect plus UX architect. What we expect from the UX architect: the ability to identify and express the information architecture. And after that, the best way for people to interact and visualize any content. Information architecture is a nice term to indicate how information flows, essentially, from the folds, the interior of the system, up to what is physically perceived and displayed to users. Let me open a brief parenthesis. When we talk about polyglot persistence, or if we talk about things like event sourcing and NoSQL tools like RavenDB or MongoDB or this or that, and they claim, rightly, the ability to persist objects as they are. Event sourcing is about another architecture-relevant approach, says, okay, look, you persist any information you have about an event. A booking has been made and entered into the system. These are the information about the booking. Flight, blah, 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 whatever it is. You change something. You don't overwrite the record you saved previously with the same ID. But you just add another record that says that the booking with the ID has been changed, and these are the new values for the fields that have changed. It means that you have to find the actual state of the booking, you have to retrieve all orders you have logged with the same ID, and replay all of them to building the current state. But in doing so, however, it takes maybe a little more time to capture the current state, to read back, to query the data, but you don't lose any single piece of information. This is the way in which banking systems work. Okay? They use a lot of optimization techniques so that if you want to know the balance of your bank account, you don't have to go through the million operations you've made in the past 20 years or the last time, the years ago that you started your bank account. There are techniques to optimize and make it faster, but that's the idea. So if you reason about in this scenario, the data you save is not the data you retrieve. And also, I mentioned event source, but I could say CQRS, another fancy name. Separation between query and commands. You write, the command takes you to write data in one format, and when you read it back, it has a different format. That, for the most part, depends on the user interface. And this is the job of the UX expert. So the software architect ensures that whatever is being persisted or just logged contains all details about the operation, the user command. The role of the other architect is making sure that the information is extracted and massaged and aggregated together, manipulated, so that it can be quickly retrieved and show up in the UI with no intermediation. An emerging architecture today is based on a separation between command stack and query stack, in which the query stack is a plain two-tier or two-layer UI directly data-bound to a quick layer where you just run entity framework queries or link queries or SQL Server query. No intermediation, no data, no complex model, just DTOs that go as we were doing 15 years ago. But the complexity is in tracking all of the things and implementing the logic server side in command. But in writing the command logic, you don't have to care about how you read it back. So you have less responsibilities to take. So everything, you have two different frameworks, stacks, with possibly different people and teams working on that, and no interaction, no dependency, if not just the physical structure of some databases. And in this regard, the role of the UX expert ensures that you can work with separated stacks at the same time so that the data that comes up to the presentation fits the expectations of users. And also, another responsibility of the UX expert is usability reviews, which is not saying I took a course on usability and I'm an expert, or I've been a designer for 20 years, so I'm an expert. It says it doesn't exclude taking classes, of course, but it mostly means talking to users, listening to user feedback, and even observing users in action with prototypes or the first releases of the final product. Even filming users. you see that. I mean, I went myself through a similar experience. I mean, I created a small software, a small website for internal purposes, right? And it was my company, we do in my company IT services for professional tennis, right? And one of the services we do for ATP, WTA tournaments is providing animations, TV overlays for whatever they do publicly. One of the things that we started doing earlier this year was animations for the draw ceremony. Now, they told me that when in a top-level tournaments, there is the draw ceremony, the position of players in the draw follow strict rules. So I read carefully the document, and I thought I created a system that, with a minimum effort, allowed users to use the operator to place the name of the player in the right position in the draw, and then exposing at the same time a service, a JSON service, to the Flash application used to create the TV overlays. So we had a guy who wrote the Flash app and the operator. Okay, a guy from the company who has to be quick to read the name of the player as it was drawn from the officer and type in the system in the right position so that it could be immediately displayed in a matter of milliseconds on TVs. Okay, for the seeded players, no problem, because we entered the list of seeded players right away, right before the system started, so it was just a number. Okay, seed number 1, 2, 3, 4, 5, and it was immediately automatic, totally automatic. Non-seeded players, they had to type. Okay, auto-completion, whatever. But actually, there were a couple of things in the overall process that, to me, when I tried the system repeatedly in my office, raised no issue at all. But when tried live during a process, they put, for the first couple of times, a lot of pressure on the operator. Okay, there was undo, so they could manage to have the show go on, but there was a lot of pressure. So they came back to me with a list of things about the usability of the system that has a software architect I never imagined was so critical. So this is what I mean by listening to the feedback and observing users live or using the system live yourself, if that is possible. It depends on the type of the system, right? But yeah, this is essentially two things. These are two things that make a huge change. And if you can catch these things quickly, you save a lot of complaints. You build a much better reputation for your customers. And in the end, trust me, you and your customers save money. Focus is the data flow, much more than just the colors, the graphics, the borders that you put on. In the end, this picture says that design can be fantastic, can be smart, but if you miss something, the user experience necessarily becomes much less enticing. And out of this, the builder gets a bad reputation because you've been such an idiot to build a great, fantastic system, but you put a bar. So in the best, I have to go rise the bar myself to pass. If I have a car, or the bar, worse yet, is fixed. Oh, I have to bend myself and pass down or jump over the bar. The system is beautiful, okay? But the user experience not necessarily is as smooth as the intentions of the designer. So for each screen, determine what comes in and out. So once you have wireframes for each screen, turn that into a class. Input model, so the data that from the UI goes into the back end of the system, and a view model, what comes from the system to populate the screen. So once you know what comes in and what comes out of a screen, for each screen, you have everything you need. You don't need, the next problem is just how you work with that information. But if you can sign off on screens for each screen, and you know, sign off what comes in and what comes out, everything else is up to you. I mean, as long as it changes, there's an explicit request for change, the data flow, having that fixed changes completely the world. It's only about you and your ability to, and your team ability to write code. At that point, you can make the application layer, which is the set of classes you call right from the UI. Talking MVC, it's the set of classes you call right from controllers, with no dependency on controllers. Because if, say, the application layer needs to process content from the session state, you don't pass the session state, but you just extract the data and pass the data into the application layer classes so that it can be tested in total isolation. And make those endpoints, the application layer has public methods. Each of these methods must be connected to an action, a button click, in some of the screens. And this button click has a basic exchange of data determined at point one, what comes in and what comes out. And finally, the application layer is a black box. You can put underneath that level whatever logic you want, and you orchestrate tasks and layers down the stack down to persistence. And like this, essentially. But whatever you do in the black box can be changed without involving too much users, with the guarantee that whatever is on top of the black box works for users. It may take ages to write the black box. In the worst case, if it takes ages to write the black box, at least you're guaranteed that users will love it in the end. Which is, well, not the ideal result, but it's much better than what we have today, what we get today, most of the time. So tools for UX architects. Essentially, the job of a UX architect is about sketching, so creating ideas, shareable ideas of what goes into each screen form, storyboarding, so building a navigation system across the screens, and, okay, creating classes, okay, out of those wireframes. A couple of tools that I know which do part of this job are Balsamiq, which is a desktop product, but also a cloud product you subscribe to, and UXPin, which is only available, as far as I know, as a cloud system. You pay on a monthly basis per usage basis. Personally, I'm a user of the desktop edition of Balsamiq. I don't like, actually, completely those tools, but both can be functional. In particular, what I don't like in both tools is their limited ability or just inability to create and test storyboards. So that users, can, okay, I say, oh, this is my home screen. Okay, I have a few buttons here. If I click this button, I would like to see automatically in an animation, in a storyboard, the next wireframe associated to this. To my knowledge, this feature is little available. It's not available, or not the way it should in the products I mentioned, and I don't know about other products that can do that. A second thing that these don't do is, okay, I have this. Can you help me generating some C# class? Maybe not the perfect class, but a class that saves me a bit of work. Now, this is a balsamic screen. Balsamic is, the source file of this is based on XML. So it's not completely impossible to create your own tool that parses this relatively simple XML, reads the name of the tag for each UI element, and generates what you define to be, I mean, for example, this is a button, so I need no UI, or perhaps just a string for the label. Or then you see maybe this is going to be a tab, so I might want to have a collection of tab objects. Or I have a text box, okay, that I need to have a read-write property for that. So simple things like this, just an helper tool to speed up the process of writing code, because you actually have to write code for the classes that describe what goes in and out of input forms. But anyway, you can go to users and show something like this. Okay, this is the home page that we're going to have. Maybe you can find in, well, not here, but in the next a few slides, text written in Italian, because this comes from a project I was working on last week. So it can be something like this. This is for a booking system. This is the form that when users want to create a new, we're talking about a tennis club, and we're talking about booking a court on a tennis club. We're talking about this. So I am this player, and I want to book a court playing with player number 2, who's going to pay, how much each pay for the fee. Okay, I want to only have friends of mine, and so forth. So this has been created looking at requirements. And next week, I will see the customer to see, okay, this is what I've taught, but it took me a couple of hours. So no big effort. So it's something billable, but you know, it's just a small bill, actually. Or, okay, when the user clicks on the profile up there, it sees something like this. So the user screen presents the avatar, basic information, change password, delete account, add Facebook credentials, or maybe personal social contact play with notes about info that you expect to see there. I'm not talking about the graphical way in which I'm going to present the Twitter account. It doesn't matter. In the social tab, I'm going to show excerpts from the Facebook page, the Twitter page, whatever the user has provided credentials for. Or maybe, okay, that's it. Okay. So this is essentially the idea. So, in summary, pillars of modern software are essentially top-down design, which is what I presented and shared in this talk. And in more concrete terms, the idea of top-down design can be implemented through bounded context at the design level. So the ability and attitude to split a business domain in smaller pieces. A bounded context is subdomain, essentially. Okay, the rules that you use to split, to recognize subdomains in a business domain and to implement them as bounded context. Bounded context is a fancy name from DDD, but essentially it's a subdomain, okay? It's a partition of the entities in the original business domain. Identifying bounded contexts, to identify them, you use ubiquitous language. So you try to learn nouns, verbs, terminology in the business. You come with a glossary. And whenever you find, and you find that, we're talking about hundreds and hundreds of words, okay? When you find that one term has two or more meanings, or the same term is used, the same term means the same, different terms mean the same thing or vice versa. The same term indicates different things. That's, you crossed the boundary of a different subdomain. You want to reason about the best way to split those concerns. It's common. It's much more common than you may think, okay? But the lesson number one from DDD is exactly that. When you cross the boundaries where the ubiquitous language, the language of the business changes, the best thing you can do is split implementation. It's different subsystems, period. Each subsystem, called bounded context, has its own ubiquitous language, so its own language of the business, and has its own implementation. The domain model, which is often associated with domain-driven design, is just one possible way of implementing a piece of the domain. So you can have multiple subdomains, so a huge domain partitioned in several subdomains, even with some overlapping. Okay? And each of these subdomains can be and should be implemented in the best way that is functional to the final system. So it could be that you have a domain model somewhere and a plain CRUD somewhere else. You can have a CRM in some places and maybe a CMS in another places. It doesn't matter. It's not true, no longer true, that one all-encompassing model for one single domain rules the world. This is the biggest mistake we can make these days. And this has to do with CQRS. Because CQRS is emerging now, has a reaction just to the idea of having a whole comprehensive model to rule all parts, all behaviors you recognize in the system. And if you do so, when you mix reads and writes together, it happens that requirements, constraints on writes affect reads and vice versa. If you focus on the stack model and the read model separately, even when you take the domain model approach you want to build for the common side, one system that rules all possible scenarios and situations, without the burden of having to read that data back, things are far, far simpler. There are typically many relationships that drive you crazy in an all-encompassing read-write model together are one-to-many, become one-to-one, or just no relationships at all in the sole context of command. This simplifies, greatly simplifies. In my book, I summarize in mathematical terms the difference between classic DDD and CQRS by saying that the complexity, where the complexity of DDD, of a DDD solution is n square, is n plus n, is 2n in CQRS. So you have the sum of the complexity of two different systems instead of having the exponent, 1 by 1. It makes a huge, huge difference. And layers, well, because each system, each subsystem is better rendered. But this is obvious, so I don't even need to spend any time pushing the importance of layers in software. Layers in software, however, are these days even more important because layers help the design. And what about tiers? Tiers these days are much less relevant. What is emerging to be concretely the best way to scale applications up is having one full stack, okay, multi-layer but single stack application, put that on a web role, web job on Azure, just if you want to talk Azure, and scale horizontally by multiplying Azure roles. That is extremely effective in terms of costs and also in terms of development. You don't have tiers, so you don't spend the time in serialization. Everything is extremely compact because it lives in the same process space. layers help design and help fixing things or replacing things, should this be the case of. Scalability, Azure does that by multiplying horizontally and makes you really as elastic with your business and your growth of business as you need to be. Okay, that's it. I've counted more than 30 of you. I need 30 people to follow me to reach the 3K, okay? 3K boundary, ideally by the end. Tell your friends if you already follow me, but anyway. Thank you very much for your time. If you have a few questions, we have some 10 minutes, so we can, because this is the end of the day. Otherwise, feel free to go to enjoy London, and thank you for your time. I think everybody can agree that most of the costs, direct and indirect, of software projects depend on user requirements, how we understand them as architects, and how we handle them, how we pass considerations, instructions that we learn from requirements to the actual people, whether ourselves, our team, or companies living the other side of the world, we outsource it to, instructions on the actual code we want to build. The second two blocks in this talking about slide refer just to what I call the solution to the issue of a different, more common sense way of handling requirements. Sign off at the presentation layer. This is the new idea, if you allow me to use this engaging word. Oh, it's a new approach. Wow, we have a genius in front of us. Okay? No, it's not like this. But anyway, UX first, related to signing off at the presentation level, is the point that says, okay, we are, at the end of the day, just selling a user experience, so a mix of graphical artifacts, whether a web page or just the front end of a client, a rich client application, to customers, and they work through the tools, graphical and logical, we provide. And the point that I feel to share is, most of the time, we miss at that point. Not much in the back end, not much in the logic, but in the way in which we offer functionalities, the experience, the way in which we build and study and arrange the final experience. So UX first is the top name for this relatively new, and I like to call it, common sense approach. Now, developers and architects, we are not completely idiots, okay? So if we do things in a way that in the end costs us some money, there should be a reason. There is a logical, extremely logical path that we apply, we use every day, that has to be revisited at least. So let's start seeing where we come from. The generation of today's architects, more or less, comes from the 90s. And in the 90s, when we learned the base ground of programming, we had a few assets that not in the same way exist today. In particular, we learned to code and architect systems relying on one powerful, extremely powerful server machine. And then just a few relatively slow personal computers, just clients and one big server. More importantly, we had Okay, imagine now you are face to face with yourself in front of a mirror. You can say that. We had for years a generation of users and users passively accepting whatever interface we were giving them. That's it. I did that, you did that, so it's everybody faced this point. So because of this mass of users, we never probably spent much time focusing on the experience, including the interface we were offering to our users. And we thought, maybe reasonably from the perspective of the 90s, we focused much more, we reckon a lot more important to focus on the database, on the optimization of the database code rather than what we were giving users, because they accept whatever we do as long as it works quickly is fine. Today, we have, unfortunately or fortunately, depends, different assets. In particular, we have so many fancy technologies. So it's no longer just about learning how to code effectively a storage procedure running within SQL Server or Oracle. There's a lot more we can do from the data level up. We have not just one or two dummy PCs, but we have myriads of client devices. And many of them belong to classes completely incompatible. A smartphone is not a PC, a laptop is not a tablet, not to mention wearables or whatever else. Whatever other fancy technology will come up and show up in a matter of months. And worse yet, we have now a mass of users not passively accepting enforcements, but actively dictating what we should be doing. So the user interface, Welcome, everybody. My name is Dino Esposito. I do some work for JetBrains, that people who are active, especially in the Microsoft stack, but not necessarily also in the Java space, know this company very well for the tools they do. What they do has not much to do, actually, with what I'm going to present in the next hour and a half or something like that. The sketchy thing and the comeback of flowcharts and top-down refer essentially to a common sense approach. I'm in doubt whether to say a new common sense approach or just a common sense approach to the whole process of software development. It comes from years of personal involvement as a developer in the beginning, but more recently as an architect and as the chief architect on projects in a very specific business domain. But managing these projects told me a few things that basically I'm ready to share and overall qualify as a new, yet another common sense approach to minimize or at least to keep under control the costs of software development. So essentially we are talking about requirements, user requirements. Consumers of our software are now totally different. And that is the generation of, well, the present, but more importantly, the future. So any piece of software, any enterprise system that has customers or end customers, some sort of consumer level in it, should take into serious account the experience that is actually provided to users. But even when the enterprise system is created as a line of business app to be used within the company. Well, money is still involved because a user experience that is less than optimal can take employees to spend a lot more time for doing the usual tasks, achieving the usual tasks they are supposed to do. So it's, in the end, instead of being a direct cost, it becomes an indirect cost, but it's still a cost to the company. So we live clearly now in a different world, but we still, in my opinion, for the most part, try to build software as if this big change in the software world never happened. In the 90s, we had powerful databases. One, SQL Server or Oracle or maybe DB2 or maybe SAP, but one big server machine. Super optimized code running within that machine. It made sense 15 years ago because the company spent a vast mass of money to have that server, and reasonably the company wanted to take the most out of that machine. So optimizing, having the wicked machine to work as hard as possible, that was precisely a way to keep costs